Good morning, dear grade 12 learners and the fellow teachers. I am Mr. Lucky Tlaba, grade 12 educator for mathematics, and today we would be looking at the number patterns under the National Tutoring Campaign. In number patterns, what is known as sequence and series, we have different types of sequences. First being the arithmetic sequence. That is the one you learned in grade 10. It also comes to be known as the linear pattern. So in arithmetic sequence, it's where we have the common or constant difference. When you subtract the two consecutive terms, you get a constant common difference. That is what we come to know as an arithmetic sequence. And for a series, we now going to add those numbers that are in sequence. Then we add them, the answer to it becomes a series. So this we have learned in grade 10 and also revised it in grade 11. We also have a quadratic sequence. Under quadratic sequence, it's whereby we have a common second difference. So in arithmetic, the first difference is the one which is constant, but in our quadratic sequence, it is the second constant difference that is the same. But for this one, we do not have a series for a quadratic sequence. In a quadratic sequence, we have a general formula for it. I'm going to be showing you the general formula for quadratic sequence as would be looking at the list of formulae. And we also have a geometric sequence. A geometric sequence is whereby now we have a constant ratio. We have a constant ratio. So if there's a constant ratio between the two consecutive terms, we say that type of a sequence is a geometric sequence. In fact, to get the next term, you have to multiply by the constant ratio. And it also have a series. And at times, you'd find that an examiner is able to give you a mixed sequence. Maybe it's a fraction whereby the numerator might be arithmetic sequence and the denominator might be your geometric sequence. So those type of sequence, now we call them that they are mixed sequence. So it can be a mixture of arithmetic and your geometric sequence. Now, what is most important, of course, is for us to know what is examinable and what is not examinable. As per the examination guideline, under the number pattern, sequence, and series, it is told that the sequence of the first differences of a quadratic number pattern is linear. That we should know that if we do the first difference in a quadratic pattern, it becomes linear. Therefore, the knowledge of a linear pattern, also known as arithmetic pattern, can be tested in the context of the quadratic number patterns. This is to say, in that quadratic number pattern, they are able to test two types of sequence, which is the quadratic number pattern itself. They can also be able to test you on the arithmetic sequence because the first difference of a quadratic number pattern is linear. And we are told that the recursive patterns will not be examined explicitly, all right? And the last part, the links must be clearly established between patterns done in earlier grades. As I've already mentioned that these patterns were done in grade 10, others were also done in grade 11. So there should be a clear link between what we have learned in grade 10, 11, and as it culminates into your grade 12. Then we have an information sheet. Remember, you're gonna be given this information sheet, or others call it a formula sheet. So this is the list of formulas that would be given to us, okay? This is the list of formulas that would be given to us. But now, the ones that we are going to be using, we're going to be using the one that says Tn is equals to A into n minus 1. We know that one is for arithmetic. Okay, so we know that that one is for arithmetic. So this particular one, this formula is going to be used for arithmetic sequence. This formula determines for us the general term of arithmetic sequence. Okay, so it gives us a general term of arithmetic sequence, or what is come to be known as the nth term of the sequence, whereby the value of A, this A is going to be our first term, and the value of D is a constant difference, and the value of n is our number of terms in that sequence. And the Tn is our general term, or the nth term. So this, dear students, please remember we use it for arithmetic sequence. All right. Now, for arithmetic series, when we now want to sum all, we use this one, okay, which is Sn, sum to nth term. It would be n, which is still the number of terms. A, as we mentioned, that the A is going to be the value of the first term, and the n, okay, is going to be the number of terms, and the D is our constant difference. So everything else is still the same. It's just that that one is Sn. And it's also important that I have to mention that we also have to know how to derive this formula of Sn. So the derivation of this formula, it's tested, so it can give you about 4 to 5 marks. So it's important that you remember how to derive the formula for sum of arithmetic. All right. Then we have this formula here, okay, the Tn. So Tn is equals to Arn minus 1. So the Tn is the general term, the A is our first term, and the R, this R is what I mentioned earlier. It's a constant ratio. The R would be the constant ratio, okay? And the N, of course, is the number of terms, okay? This one, we use it for geometric sequence, okay? So please remember, this one is for geometric sequence. This one is for arithmetic sequence, okay? This one is for our arithmetic sequence, okay? So also in geometric sequence, we have the sum for geometric sequence. So if we need to get a sum for geometric sequence, which is Sn, there it is, okay? Our Sn, it's A into R to the power of n minus 1. So the A would remain the first term, and the R is the constant ratio. Remember, R is the constant ratio. And how do we get R? R is equals to term number 2, okay, when it's divided by term number 1. Please do not forget how to get your R, okay? So it's important that you know how to get your R. Now we also have the concept known as the sum to infinity, all right? So you guys remember that our series is able to converge, okay? So if it's able to converge, we say it will go to infinity. But for the sequence to converge, there is the condition, okay? So the sequence can only converge if R is minus 1, is greater than minus 1, but R is less than 1, okay? So then the sequence in this particular case is gonna be able to converge, all right? But if the condition is not met, then the sequence is not going to be able to converge. But if now it converges, we are able to get the sum to infinity. Okay, we are able to get the sum to infinity. So sum to infinity, it's a over 1 minus r. So where a is our first term and the r is the constant ratio. Okay, so it's important that you remember that your r would be your constant ratio. All right, so this is the formulas for geometric sequence, okay, for sum and also for sum to infinity. You'd realize that there is no formula given for you for quadratic sequence, okay? So there's no formula given for you for quadratic sequence. So it's important that you know that quadratic sequence, how do you get it, okay? For quadratic sequence, this is how we get it. It has a formula. We say Tn, okay? For quadratic sequence, we say Tn is equals to, okay, a n squared, okay, plus bn, all right, plus c. Please remember, this is now the general formula for quadratic sequence. Please make sure that you know this formula by heart, because it's not going to be given the formula sheet, okay? So this was adapted from formula sheet. So make sure in this empty space in the formula sheet where they did not write anything, do put for yourself the formula for quadratic sequence, okay? So those are the list of the formulas that we're gonna be using today to solve our questions, okay? I think you are familiar with these formulas, and make sure that you copy the formulas in the correct order as they are given to us, all right? So now let's move further. Just to quickly remind you, you're gonna be writing paper 1 and 2 out of 450 for 3 hours. And the number patterns, which is sequence and series, as it's the one that start in paper 1 up there, okay? So this is the one that we are gonna be focusing on for today, okay? We're gonna be focusing on the number pattern, sequence and series, all right? So let's check as to how many marks are we expecting to get from this particular topic, okay? Let's check how many marks are we going to be getting from this particular topic. This was just part of the format of the paper, which I shared with you last week. Now let's look at the weighting of the paper, all right? Last week, we have done algebra, equations, and equality. I hope you enjoyed your the session of last week. So we were able to make about 25 marks. And today, of course, today also, we are going to be looking at the topic which weighs about 25 marks. Look at the number of marks. There is the number of marks. It's a paper 1 topic. The number of marks is 25 marks. And as I've said, we are doing number patterns, okay? So by the end of the lesson, we should be in the position to get our 25 marks, all right? So another important thing that I wanted to highlight, every now and then I'll show you the instructions and information, but the most important one that I want to highlight for today, it would be that please answer all questions. In mathematics, there's no optional questions. We answer all questions because no marks would be awarded for empty spaces. And of course, numbering is very important. We number exactly as the numbering system used in the question paper, okay? We never get full marks if we do not show all the calculations. Please do show that all the calculations which has been used, you need to show so as you can be awarded the full marks for the question, okay? And now, also, it's important that we remember to take with the scientific calculators, the approved scientific calculator. It means that is non-programmable nor graphical, okay, unless it is stated otherwise. Okay, if necessary, please remember that our final answer, we round it off to 2 decimal places, all right? And of course, the diagrams that would be given to us are not necessarily drawn to scale. Okay, so that is important. And the information sheet is the one that I've just shared with you, okay? There's an information sheet with the formula. It's usually included at the end of the question paper. So these instructions, guys, are very, very important. And of course, the last one, it's advisable that you write neatly and legibly. Okay. All right. Now I think we are in a position to go. We are in a position to go and look at the typical questions that they can give us. Okay. So let's go to typical questions. So there is the question 2.1. Okay. In 2.1, we have 7 is to x is to y is to minus 11. We are told something important. We are told that this is an arithmetic sequence. Okay, we are told that it's an arithmetic sequence. So remember, if we are not told the type of sequence, we have to find a method to check whether it's arithmetic, whether it's quadratic or geometric. But if they have told us, the question becomes even more easier for us to work with, because we were told that it's arithmetic sequence. We know the formulas associated with arithmetic sequence. Okay. So in this particular question, I think you can see already, we have 7, x, 11, and minus 1. Okay. So now let's now attempt to answer 2.1. Okay. Let's attempt to answer 2.1. Okay. We will jump these others and we'll revert back to them shortly. All right. Let's try to answer 2.1. So they want us to determine x and y. All right. So we have 7. All right. We have 7, we have x. Okay. We've got y. And we have also minus 11. So we are told to get x and y. All right. So the first thing that we know is the following. All right. We've got the first term. There is our first term. The 7 is our first term. So if you like, you can just say a would be equal to 7. All right. That's the first information that is given to us. And we also have the fourth term. I think you can see the fourth term, which is minus 11. Okay. You know that the fourth term would be a plus, okay, it would be a plus 3d. If we want to go to the fourth term, we have to add 3 differences from the first term. So a plus 3d should be equal to minus 11. Okay, so this one we know. Now, what it is that we do not know now? We don't know the x and the y. So from this, it's easy. I think you can agree with me. You've got the value of a, which is 7. You can just substitute 7 plus 3d, okay, is equals to minus 11. All right. 7 plus 3d is equals to minus 11. From there, we can be able to get the difference. When you take the 7 the other side, you would be able to get the difference. So now we can get that our d, okay, it would be minus 6. Okay, so the value of d would be minus 6. All right. So if we have the value of D as -6, then we do not have a problem. We can get our X. Now remember, our X in this particular case, okay, our X is going to be equal to A plus D because it's a second term. Okay, X is a second term, so it's just A plus D. I think you remember that. Then you've got the value of A, which is 7. You've got the value of D, which is -6. So ultimately just going to be 7 minus 6. Okay, it's gonna be 7 minus 6, which is going to work out to 1. Okay, then we can also get the Y. The Y is a third term. So if it's a third term, it would be A plus 2D. Okay, A plus 2D. We've got the value of A at 7, of D as -6. I think you remember, D is -6. We put it in bracket. Okay. Then when you work it all out, you get the value of Y to be -5. So you now have the value of Y. You also have the value of X. So that is how you have to get the two unknowns. Okay. So that's one method. Of course, there are several other methods that perhaps your teachers have shared with you, as long as you are able to arrive at the same answer, and those methods would be allowed and they are correct. Okay, so that is how this question was going to be solved. So we are going to be awarded the mark for this step. We're going to be awarded the mark for getting a difference, and of course for value of X, and of course for value of Y. So that was going to be our good 4 marks. Okay, and of course this is question 2.1. All right, so that is how you were supposed to have answered that particular question. Okay, so let's go to now question 2.2. Okay, let's go to question 2.2. So let's read the problem statement. Given the quadratic number pattern, there is the number pattern which is given to us, -3, -6, -3, 6, 27, and 60, and the other terms which are following. It's important that you see that there are other terms following, so as you cannot think that this is your last term. Okay, then let's check the questions. The first question, it wants us to determine the general term, the Tn. They even gave us in which format. Okay, so they even gave us in which format, which is the format I told you have to learn it by heart. So please make sure that you know how to get your Tn. All right, so we are going to get the Tn. Thereafter, we would look at the subsequent question. So for now, let's just go and get our Tn. Okay, let's get an empty sheet where we can get the answers. Okay, so now let's look at 2.2.1. Okay, so we are going to look at 2.2.1. Now in 2.2.1, okay, so it's 2.2, okay, 0.1. All right, so what do we have? Let's just write the sequence which is given to us. The sequence as it's given to us, it's -3, okay? It's -3, it's 6, okay? It's 27, all right? And the last one given, it's 60. So guys, I think you remember when we are working with a quadratic number pattern, we have a way to solve it. Okay, it's a standard way. The first thing, we get the first difference, which is this term, subtract by that other term. Okay, so when you say 9 subtract minus 3, you get 9. So 6 minus 3, you get 9. Then you come here, you say 27 subtract 6, you get 21. Okay, then you come here, you say 60 when it's being subtracted to 27, then you get 33. Okay, after that, this is your first difference, by the way. You get your second difference, so it's gonna be 21 subtract 9, then the answer worked out to be 12. Then you say 33 subtract 21, the answer worked out to be 12 again. Okay, anyway, we are told that it's a quadratic sequence, so we expected the second constant difference to be the same. All right, thereafter, guys, you know the number here, okay, the number here, we equate it to what? To 2a. The number here, we equate it to 3a plus b. The number here, we equate it to a plus b plus c. All right, that one I'm sure you remember. Okay, it was done in grade 11. 2a is going to be equal to 12, as I've said. Okay, then from here, you can see you can divide by 2 both sides, and then you can get the value of a to be 6. Okay, then the number here we said is going to be what? 3a plus b. So 3a plus b would be equal to 9. Okay, this would be equal to 9. Okay, then you substitute the value of a, which is 6. All right, now we want to get the value of b. Okay, this would give us 18. 3 by 6 is 18. Then you say 9 minus 18. I think the answer then work out to be minus 9. Okay, the last step, this first term of the quadratic sequence, it becomes a plus b plus c is equal to 0. Okay, a plus b plus c is equals to minus 3. Okay, there is our minus 3. It should be equal to minus 3. Okay, there is our minus 3. We have the value of a as 6. We've got the value of b as minus 9. We have the value of c. Okay, we have the value of c. Now we calculate. Then when you calculate, you come to realize that the value of c is going to be equal to 0, because 6 minus 9 is minus 3. Minus 3 plus 3 is 0. So now our formula for Tn, remember, formula for Tn, okay, it's a n squared, okay, plus bn, okay, plus c. Now we have the formula. We can just substitute, then it works out to 6 n to the power of 2 plus, okay, but now the b is minus, so it would be minus 9. okay, to the power of n. Ultimately, this is the same as 6, okay, 6n squared minus 9n. Good, that would be the answer. And it's important that we see how the marks are going to be allocated, okay? It's good that we know how marks would be allocated to us. So we're gonna get the mark for second difference, okay? Mark for second difference and mark for value of A, of B, and of C, okay? So that's how marks would be distributed in this particular question. And yes, that is our good 4 marks. Guys, it should be easy to work it out, okay? So now let's look at the subsequent question, which is 2.2.2, okay? Now let's go back to the original question. Calculate the value of the 50th term of the pattern. So now they want to know the value of the 50th term. So they want T50. We're gonna go to the formula that we just got. Then when we see n, we now substitute 50, okay? So let's get an empty space. Then we have 2.2, okay. So there is our 2.2, okay. So 2.2.2. So we want T50. So where we see n, we're now going to put 50. So T50 is going to be equal to 6, all right? Then we are going to substitute 50. Okay. We just have to remember to square. Guys, this is substituting in the formula that we just got. Okay. We substitute in the formula that we just got. Where we see n, we put 50. Okay. Just to remind you, this is the formula. The formula was 6n squared, okay, minus 9n. So where we see n, we put what? We put 50. Where we see n, we put 50, okay? Then we press in the calculator. We don't forget to square. And when we press in our calculator, T50 is going to be 145, okay? 14550, okay? Which is 14,550. Yes, then you are going to be getting your marks for substitution, of course, and they're gonna be a mark for a final answer. All right, so now we can go to the next question. Okay, so let's revert back to the next question. Show that the sum of the first n difference of this pattern can be given s. So they want us to show that Sn, it would be Sn squared plus 3n. So we go to the first difference, then we calculate Sn. That's what basically they are trying to say to us. Okay. So let's go to the first difference and calculate n. Okay. But it's important that we remember what is our first difference. I think you can see here the first difference. There is a first difference. Okay. If I can highlight it for you, there is our first difference. It's 9, 21, and 33. So we are going to go there and calculate Sn. Okay. 9, 21, and 33. Now, let's do exactly that. Calculate Sn. They told us what the answer we expect it to be. Okay. So as you remember, this is our 2.2.3. Okay. 2.2.3. So we have 9, that first difference has the following: 9, 21, and the last one was 33. Now the value of A, you can see the value of A. This will be our value of A, okay? And if we take this and this, we subtract them together, 21 minus 9, we are going to get our D, which is a constant difference. And the D in this particular case would be 12. Okay, so now we can now substitute this in our formula of Sn. All right, so you've got the formula of Sn, the one that come from formula sheet, remember. Then you say it's n all over 2. Okay, it's n all over 2 it's n all over 2, open bracket, 2a into n minus 1, all bracket, okay? Then it's multiplied by d. The formula, guys, we are going to get it from the formula sheet. Make sure that you consult the formula sheet and you copy it as is. Then we can now just substitute. We can now just substitute. So we can substitute n, we do not have, we only have a and d. So we leave n as is, then is 2 multiply, okay? It's gonna be multiplied by 9, okay? Which is our a, plus, here now we have what? N, we don't, sorry about that. We don't know the value of n, okay? We don't know the value of n. It's gonna be now n minus 1 into the value of d is 12. All right. Yes, then now after you get this, you multiply everything out. When you multiply everything out and remove the bracket, you'd see that your answer would work out nicely to what? To 6n squared, okay, plus 3n, just the way they wanted us to show, okay? So what is left is just for us to multiply everything out, then the answer is going to work out nicely to this. Okay, so basically that is how they wanted us to work out the answer. All right, so it was not that difficult at all. It was just a sum of first difference. Okay, so now let's go back and check the other question. So now how many consecutive first difference were added to the first term, okay, to obtain a term in a quadratic that has a value of 21060, okay, 21,060. So now let's go to the free space so as we can get our answer. Okay, so now in this particular case, we were needed to get the number of terms, okay? We are needed to get the number of terms. So now what are we going to do? We are going to say minus 3, okay? Minus 3, which was our first difference. This is 2.4. Okay. So 2.2.4, then we are going to have minus 3 plus Sn is equal to 21060. Okay, so now from here, now you are able to get your Sn. Okay, you just take the -3 the other side, it becomes 21063. 21063. All right, then we already have the value of Sn. Remember, we got that Sn is 6n squared, okay, plus 3n, okay, is equal to 21063. Okay, this one, it was given to us, the Sn. Remember in the previous question that we had to prove it. From here, I think you guys can see you're going to take everything to the left. It's like now last week when we were doing algebra, how to solve, you take everything to the left, then we equate it to 0. Okay, you equate it to 0. All right, after here, you guys should know that because we cannot easily get the factors, now we have to use quadratic formula. Okay, please use quadratic formula, and when you use quadratic formula, your answer for n, they're gonna be 2 answers. One would be 59. Okay, one would be 59, and the other one, okay, one will be 59, and the other one would give us negative 112 divided by 2. So that will be the next answer, okay, which is negative 119 all over 2. But remember, the n cannot be negative. The n cannot be a fraction because it's a number of terms. We are calculating terms. As a result, now we cancel this one out and we say no, n cannot be a negative. So our only value that we are left with now is that one, that n is going to be equal to 59. That would be the only value of n. Remember, to move from here, we use quadratic formula. Okay, to move from here, we use quadratic formula as we did last time. And of course, from there, you are able to get your value of n. Okay, so there are 59 first differences that must be added. And yeah, that was the last question for the class activities that we had. Okay, that was the last question for class activities that we had. All right, and please, you can look at this as your home activity. Okay, please look at this one as a home activity for your sigma notation. Okay, so please look at this one as your homework. Okay, this is your homework. All right, so please go and look at this one as your homework. It's about sigma notation. Okay, converging geometric sequence, we spoke about it. Okay, so yeah, that is all I can give you. And also just a hint, remember, if they said is equals to this, it means it's your s to infinity. Okay, if they say is equal to this, it's your s to infinity. Please look at that one as your homework. And yes, I would mark it with you next week, as would be working on the other topics. Okay, and yeah, thank you very much for your time. I really enjoyed my session with you. I'm going to open a floor for questions, if there are any. While waiting for the questions, just to keep you abreast of what's going to happen next week. Next week, we would be looking at the functions and graphs. Okay, so please prepare yourself for next week. It's functions and graphs. And I really hope we would meet each other next week. And until then, I thank you. I'm still opening floor for questions.